Greetings, Internet users. We wonder if there is anything at rest in the universe. There should exist some object without any movement, far from the influence of gravity, somewhere. However, even though we may think we are standing still, we are actually traveling at a great speed through space, following the Earth's movement in its orbit around the Sun and within the galaxy. Yet, we don't perceive this motion because it is constant, and other vectors of velocity, like riding in a car or plane, only become noticeable through acceleration or sudden braking. If the Earth were to suddenly stop rotating, we would feel the effects of inertia, and we'd be thrown away. Fortunately, the universe operates like an extraordinary Swiss clock, according to relativity. No matter how far away you are, gravity waves travel through the fabric of spacetime at the speed of light. However, their effect diminishes with distance. Therefore, if the Sun were to disappear, the Earth wouldn't notice its absence until 8 minutes later, as the light and gravitational influence would take that time to reach us. This aligns with Einstein's theory of relativity, where gravitational waves travel at the speed of light, as demonstrated by the detection of gravitational waves from the collision and fusion of two black holes at the LIGO Observatory. If you observe the planets, they move around the Sun, and this movement also originated from the original nebula, which also rotated to create the Sun. Going back in time, we can find objects with more movements that have been inherited by the current inertia in our solar system, giving rise to stars and planets. Even galaxies spin and always conserve their angular momentum. Billions of galaxies rotate in an intricate network of clusters and superclusters. The largest galactic clusters tend to merge, forming extraordinary galactic networks composed of dark matter and ordinary matter. Any object tends to retain its movement unless acted upon by another force. This occurred with Venus and Uranus, whose rotation differs from the other planets, possibly due to past collisions. But what would happen if we removed the planets and the Sun and found ourselves in empty space, the Milky Way? Surprisingly, we would still be moving through the galaxy and would feel the effects of nearby stars like Proxima Centauri or Barnard's star, which would displace us only by a few tenths of a millimeter each day. Despite the vast distance, being in absolute rest seems impossible because it would mean an object whose position in time does not vary, and we always measure movement with respect to something else. So, even if we find a body at rest with respect to another, we can always find another object as a reference. The only way we wouldn't be able to measure our movement is if we had an astronaut in space, in the middle of nowhere, with nothing to measure against. There would be no reference point, and we wouldn't know that we are moving. Now, you can see things moving because you are calculating their motion relative to the screen of your computer. But if you were there, you'd be completely alone and lost without a frame of reference. Thus, our universe, filled with moving objects, is all relative to the observer. It depends on your movement and the reference system you use to measure your velocity. For example, the Apollo 11 spacecraft on its way to the Moon was moving at almost 11 kilometers per second relative to Earth, over 29 kilometers per second relative to the Sun, and 227 kilometers per second relative to the galactic center. Inertia and constant velocities allow us to continually add more velocity vectors. There is no absolute velocity for an object. Rather, there are reference systems moving relative to something else. In our universe, any object with mass deforms the fabric of spacetime, causing gravitational waves that diminish over distance. And if that wasn't enough, the universe's expansion continues to accelerate, pushing distant galaxies away from each other, preventing absolute rest. If we place two objects in space without any other force acting on them, the object with less mass would be attracted to the one with greater mass. If the mass difference is small, it may take time for them to attract, but eventually, they will collide. The fabric of spacetime is still not fully understood, but it's composed of quantum energy, and we can deform that energy. Sometimes, a body has so much mass that it collapses under its gravity, becoming smaller. For example, the molecular cloud that formed our Sun or a massive star exploding into a supernova can form a black hole, where the fabric of spacetime is maximally deformed, and nothing, not even light, can escape. Though we think of black holes as massive objects that consume everything, they are actually small objects with tremendous mass compressed into a tiny space, like squeezing the Earth to the size of a marble. Even black holes move, they are not static objects. According to cosmologist Jan Levin, black holes can collide, and it's the most powerful event in the universe, releasing vast amounts of energy into the fabric of spacetime. What we call gravitational waves are a phenomenon in the darkness as they do not emit light. However, if we capture the resonance of these waves, in any case, if we were to stop all movements of any object in the universe, we could never truly achieve it because it would start moving again. The explanation lies in the quantum world. Gravity is considered the weakest of the fundamental forces, yet it still interacts with the massive objects in the universe. However, there are other more powerful fundamental forces in the universe, such as electromagnetism, which manifests through electric and magnetic fields due to the circulation of electrons, and others at the quantum level that prevent matter from breaking down, like the strong nuclear force, which holds atomic nuclei together, and the weak nuclear force, which arises from radioactive decay and transformation of matter. In quantum mechanics, all subatomic particles move in random positions, and it's impossible to know their exact position due to Heisenberg's uncertainty principle. We cannot stop them, it's as if they have their own consciousness. These particles move following various states in random positions, and it's only when we measure that state that we can locate the particle in a specific position, either as a wave or a particle, like seeing a frame from a movie or a collapse into a single state. But the nature of the quantum world is chaotic. We cannot predict where a particular particle will be or at what speed it travels. There are only possibilities. The nature of the quantum world prohibits us from knowing its deepest mysteries. Subatomic particles that form atoms also don't stop moving and transfer energy to other systems. According to quantum field theory, energy is in continuous motion and transformation. A field does not have fixed energy at any given moment. In a vacuum, energy constantly fluctuates. For example, my cup of coffee has changed a lot in the last 5 minutes, water molecules have evaporated, atoms have lost energy, and as a result, it has cooled down. This concept applies to the entire universe. Nothing can be in absolute rest because if it were, the universe would not exist, and it would not change. Even if an object reaches absolute zero, which is minus 273.15 degrees Celsius, atomic activity stops, but there is still an infinitesimal residual energy called zero-point energy that cannot be eliminated. Quantum rules prohibit rest. Regardless of the state, the entire system must continually work. The universe is what it is because everything is in motion. The eternal energy of the vacuum can never be eliminated and created this universe through quantum fluctuations, exciting atoms so they don't stop. It's a dynamic system where there is no rest, and all systems must change. That's why it survives, and we are here. Even when the universe approaches its end, there will always be eternal dynamic energy that will make it change again. The result of rest would be equivalent to absolute nothingness. So, if you think you are lazy, you are going against the universal laws. But here's some good news, your particles keep moving, and your entire body works to keep you alive, including your brain, which never rests. This is evidence that something exists instead of nothing. Newton revealed the secrets of celestial motion through forces, although he firmly believed in a static universe where time is the same for everyone. With Einstein, we went a step further and discovered that time is relative and everything is in motion. Despite his resistance to believe in a dynamic and changing universe, an unchanging eternity was synonymous with perfection. Today, through quantum mechanics and its variant, string theory, we are told that the universe vibrates and never stops, like a cosmic symphony that continues through vibrating energy strings. Some might call it the eternal music of God, playing extraordinary chords so that nothing remains motionless and everything vibrates through time. Rest is not an option, it's a prohibition. Our true nature is quantum, chaotic, unpredictable. We are mortal humans, but entities of eternal energy. If you liked this video, give it a like and don't forget to subscribe, share on social media, and leave your comments.